So, second talk for tonight. I'm going to talk about Glimmer. The talk has the nice name, Feel the Glimmer. I said it in the introduction. I need to say it again, so it's on video. This was not my invention, but 201 created a consultancy from the US, used that on their EmberConf giveaway that they had in the swag bags, I think 1 or 2 years ago. So have to give them credit for this nice title for the talk. My name is Marco. I'm Marco W on GitHub and Twitter. I work at Simp Labs. We're a local consultancy here from Munich. We do mostly those three things. Actually, mostly the things on the side, so Ember and Phoenix, and a bit of Rails as well. We do like team augmentation and consulting, code reviews, workshops and trainings. So if you need any help, then let us know. But back to the topic. I want to talk about Glimmer.js. Who has heard about Glimmer.js already? Okay, so that's about half of the people. Who has looked into it and maybe used it for demo project? 1 person? 2 people. Okay, that's great. So it's going to be something new. So the short description of the project, kind of the tagline, is lightweight UI components for the web. So it's really just a component library that you can build to use like lightweight applications. It's based on the Glimmer VM, or version 2 of the Glimmer VM. That's important, actually. And the Glimmer VM is Ember's super fast rendering engine that was released a few Ember versions ago. And since the Glimmer VM is really the core of Glimmer.js, I want to talk about how that works a bit first, so we understand like the framework a bit better than, or like the library on top of Glimmer VM a bit better. But in order to talk about how the Glimmer VM works, I first would like to talk about how other popular ways of syncing state and DOM in browsers work. And whenever we talk about something popular in front-end tooling, then it's always about React, obviously. React, as all of you probably know, uses a virtual DOM approach to sync like their application state and the DOM. And when you use virtual DOM, then how that works is you have an in-memory representation of the DOM that you can diff the changes you're going to make to, and then only apply the changes to the underlying actual DOM, so you don't have to diff against the actual DOM, which would be extremely slow. So an example for that is here we have an initial state. It's a UL with 2 li children with like 2 people. This is pseudocode, though. This is not actually an actual representation of the virtual DOM that React uses, but it's like I said, purely pseudocode. So you might have an initial state like that. You have 1 UL with 2 li children, and then for one the text is Ben Abramov, and for the other one the text is Ben Alpert. And then you have a state change where you remove Ben Alpert from the list and add Sebastian Mark. I have no idea how to pronounce that. Probably somebody knows. Mark. Right, good. So you can diff those 2 states, and then the difference is at the bottom here. So you see you have 1 new li that with Sebastian Markbach, and 1 that's been removed, which is Ben Alpert. So you can only apply that diff to the actual DOM. So you make like the smallest possible modification to the DOM that you can do. So it's like as fast as it can be. That's the underlying mechanism how virtual DOM works. You can of course do some additional improvements here. So here, because you're changing the second li, you can potentially not remove the element first and then add another one. Maybe you can just replace its text or so, which might be faster than like removing it and adding a new one. Like you can do some optimizations, but the underlying principle behind virtual DOM is this, like having a virtual DOM representation in memory and diffing that, and then applying the diffs to the real DOM. In contrast to this, the Glimmer VM is actually a pipeline that has 3 steps, and we'll go through them one by one. So first of all, you have the pre-compilation step. Second, you have the initial render step. And then the third step is a number of subsequent re-renders when your state changes. And like I said, we'll go through them one by one. So first of all, we'll look at the pre-compilation step. And the pre-compilation step is where templates are compiled into opcodes that are then executed by the VM that runs in the browser. Let's look at an example for this. So if we have this handlebars template, and of course, like Ember, Glimmer uses handlebars templates instead of things like JSX or so. So if we have this template, then during the pre-compilation step, this is turned into this set of opcodes. So you see we have like, it looks like a one-to-one representation. It's actually pretty simple. So our first opcode is 6 and UL, and I think 6 is probably open element. And then second one is 9 class, nav tabs. There's probably 9 is probably attribute, and then class is attribute name, and then the third thing in the array is the value for the attribute. And then we have opcodes for everything that we had in the template previously. And this is called the Glimmer VM wire format. This is called wire format because that's what is being sent over the wire to the browser when the application is loaded and starts up there. In previous versions of Ember, we used to compile handlebars templates into functions, which produced a much larger compiled output, which is obviously bad for sending that over the wire because you have to send more stuff to the user, so the app takes longer to load. Also, because it was a function with all kinds of things happening in there, the browser had to parse that, and Benedict just talked about how bad parsing can be if there's a lot to parse, and this is just sent as an array, which is probably simpler to parse than a function, I would suppose.
That's JSON. JSON is fast.
Yeah, so like you don't really have to do anything, right? Also, because we compile to opcodes instead of functions now, the template size is dramatically reduced. So I think like real-world apps saw bundle size reductions between 50 and 80% because a lot of applications would actually consist mostly of templates, and then if you reduce them significantly or shrink them significantly, that's going to have a huge impact, of course. So we have these opcodes now. So the next step in the render pipeline kind of is performing the initial render, which is basically going through these opcodes and creating the respective nodes in the DOM tree. A second thing, the Glimmer VM that's handling this is called the append VM because Glimmer actually consists of two virtual machines. We have one for the initial render, which is the append VM, and then we have one for update renders, which is the update VM, and we'll look at that later on. So what happens during initial render is that the append VM goes through the opcodes and creates the respective DOM nodes, and also generates opcodes for the update VM that will be used then to update the DOM tree later when the application state that backs the template or the DOM tree does change. And making that difference between initial render and update render is important because when you look at a template like this, obviously you have to render the full thing in initial render, but by just looking at the template, you can already identify the things that might be relevant for update renders and all the things that will never be relevant for update renders because they're static. So if we look at the template here, then the only things that can actually change are the things between curly braces. So everything else can be ignored during update renders. Like you never have to re-render the class of the UL tag on updates because that is static, that will never change. Right? Unless you remove the component, but that's a different thing. When the append VM generates the opcodes for update renders or for re-renders, it basically ignores everything that is static and that it knows will never change and will never be relevant for the update VM. So the update opcodes for this template might look like this, and this is again pseudocode. There's no actual wire format for updated opcodes because you never need to serialize them. You never have to like send them anywhere. They only exist during application runtime. But you see that as opposed to the long list of opcodes for the initial render, we only have 3 opcodes for the 3 potentially dynamic things that we have in the template because everything else is just not relevant for re-renders. And we can tell that certainly by just looking at the template. So we had the pre-compiled step, we had the initial render step, and then the third step obviously is the update renders, which would basically just execute these update opcodes and update the DOM if the values that the update opcodes represent kind of actually have changed. Obviously, it's important to have a good mechanism for finding out whether the values actually have changed, because here we don't have a virtual DOM in memory that we could diff the new application state against. So first thing to do maybe naively would be diffing against the real DOM, but then that's super slow, of course. So we have to find a nice way of finding out whether an update opcode actually has to update the DOM or not, right? Because the profile value here might have changed, doesn't mean it actually has changed. And if we can prevent a re-render or an update of the A tags in a text, that's obviously a very good thing, right? So the solution for that the Glimmer VM has is called references. And who has read that document in the Glimmer repository about references and tags and stuff? Okay, one person. So this is actually pretty hard and complex. So I hope I prepared it so that it will be understandable. But like I said, it's not so simple. So bear with me, and maybe it works out. So in this example, or let me take a step back. So the first thing to understand is that Glimmer represents anything that's potentially dynamic in a template by a reference. And a reference is basically just a wrapper thing about a value that you want to use in a template. So in this example here, we have this is all TypeScript, by the way. We will see why that is later on. So in this example here, we have a variable foo, which is 1, and then we have a reference to that. And the reference has a value method that would just return the value of the variable foo. Right? So if we call here the first time, we get 1, and then if we increment foo, we get 2. Right? So pretty straightforward, pretty simple. What this allows us to do, though, is to pass the reference to the variable around as opposed to passing the actual value of foo. Right? References can also be composed. So here we have two references, foo reference and bar reference. They're basically the same thing as on the previous slide. And then we have a foo plus bar reference that contains the sum of the other two references, and it behaves as you would expect. Composed references have to be pure. That means they can only depend on their inputs. So foo plus bar reference can only depend, or the value of its value method can only depend on foo reference and bar reference, and not some global state. So these are references. And so now we have a value, or a thing that we can call value on to get the actual value that we want to insert into the DOM there. But of course, we still haven't figured out how can we prevent calling value in case the value does not actually have changed. Because computing the value might be a very expensive operation, right? Like here it's very simple, but in a regular application it might be very costly, right? So you want to prevent that whenever possible. And the mechanism that Glimmer uses for that is called tags. Here we have an interface entity tag, which has a value method again, which just returns some token. We don't care what it is. It's just some opaque token, and then we have a validate method that we can pass the token into, and when the token is still valid, it would return true, otherwise false. Right? So we have a mechanism to validate the freshness of something that we have a token for. And then obviously we want to use such a tag in a reference. So here we have an interface tag, which defines a tag property that is of type entity tag. So that means we can have a tag reference that would then have a value method itself, as we saw with the previous reference examples, where they would return the value of the reference. And it also has a tag property that gives us a tag that we can call value on as well. So we get the value of the tag for that reference. Let's look at a more concrete example. In this example here, we have a person, which is, we call it a tracked object here, which has a tag. It's a .yabl tag. It's slightly different words, but the mechanism are the same. Here, so we have a person with a tag and a name, and then we have a reference to the person's name. So the value method of the reference returns the name of the person, and then also the name reference has a tag, and that's just the person's tag. So what we can do when we call that the first time here, we get the initial value of the name property from the value method, and the initial value of the tag is 1, but like I said, that's an opaque value. We don't really care what it is. Then when we mutate, or when we modify the name property of the person and call tag validate, it returns false because the name property has been modified, so the token that we have is no longer valid. And we also see that, we receive false from the validate method, and also the value of the reference actually has changed. And because the value has changed, we also get a different value for the tag. Right? So what that means is that whenever we do re-renders, as long as we know the previous value of the tag, we can just compare that to or we can just validate that. And when we have integer tags, then that means that validating the freshness of anything really that we want to render is just an integer comparison, which is probably a fast operation, I guess.
That's fun.
Yeah. So this is actually pretty cool, and this is like the second big thing kind of that the Glimmer VM does besides using these opcodes and optimizing that part of the rendering process. To be a bit more concrete in terms of how this works in Glimmer.js, yeah.
So the only reason you have a tag on every reference is that the integer comparison is faster than a string comparison? So why don't you compare the values?
Because the value could be anything. You don't know what it is. It's not necessarily a string.
The idea was also, at least the first idea, to have it running on WebAssembly before at some point, and things are not really handled in WebAssembly.
Right. So question was, why don't you compare the values? Answer is because value could be anything, and because this might run on WebAssembly and strings are not handled that well. I don't really know the details about that. But okay, I see.
One question, please. If you change the value once and then you change it back, then is it still dirty? Maybe you change from 1 to 2 and then back to 1, and is it still dirty?
That's a good question. Mean that.
How would you know if you don't track the value? You kind of, if you only have the version,
Well, it just boils down to the question whether you compare values or whether you compare like timestamps or something.
No, I wanted to get to the point, like how that works in detail in Ember.js now. So in Ember.js, any change to anything that you want to have reflected in the DOM has to go through the set method. This is Ember set, which is also present as a set on the Ember object prototype. So anything that is a modification that you want to have automatically, where you want to have the value automatically be updated in the template, has to go through set. So what we do in Ember.js is we have a global revision counter that is basically incremented every time anyone calls set, and then the value of the tag for the thing that was mutated, so in this case person, is set to the new revision counter. Right. So in your example, what would happen is that you would call set on the person once, would increment the revision counter, let's say to, I don't know, 405. So the value of the tag for the person would be 405. You modify the value again. So it would increment the revision counter to 406, would set the value of the tag for the person to 406. So you have two modifications. However, in Ember, we have a run loop. So if you do both modifications in the same run loop, you would not actually see two re-renders. I'm not sure whether it makes any sense to only increment the revision counter once per run loop or so, but that's really Ember specific and not Glimmer VM specific. So in order to prevent things like that, you would probably have some sort of run loop mechanism or so.
Another question. So basically, you have to only set something, and the rendering will be called upon this counter, or we should explicitly somewhere call the render.
Yeah, you don't in Ember. You don't call that explicitly. We just call render once per run loop, and then it maybe doesn't do anything because all the tags are still fresh. How that works in Glimmer.js, we'll see that later. You don't have to call that yourself, but we see that re-render is scheduled in the template, in the application somewhere. But we look into a real-world sample app, and then see how that works in detail. So main takeaway here is that we can, with that reference and tagging system, we can now validate freshness of anything by just comparing two integers, which is pretty fast. So here's some pseudocode again for an update opcode. The update, the opcode somehow holds the value, which is a reference. and knows the tag and knows the element. So whenever the opcode is executed, it would just validate its tag. If the tag is still valid, it would basically be a no op. If it's not valid anymore, it would do whatever that opcode thing is supposed to do. So it might be, I think there are opcodes for, I don't know, updating attribute values or so, for example. Right? So for all those like DOM manipulation things, you will have different opcodes. But the main takeaway here is that they would always validate their tags first. If the tag is still valid, they would basically not do anything because like the value hasn't changed and the DOM is still in sync with the state, with the app state. So what all these things that I talked about lead to is actually pretty good rendering performance. So on initial render, these are some benchmarks from Yehuda's blog post. They somehow resemble like real-world applications where a relevant part of the templates is actually static content, so they represent kind of real-world application scenarios where you always have a lot of HTML that never changes, obviously. So initial render is like pretty nice, not amazingly fast, but it's still pretty good. Obviously, we have to do some bookkeeping by creating those update opcodes. So that is some like additional thing that we have to do on initial render besides doing the actual rendering of the initial state. But because we do that bookkeeping during initial render, then we can be super fast in real renders, which is pretty nice. It was like a massive performance improvement for Ember when this was released, and it's really fast now. So I think the main thing that we as the Ember community gain from that is we can finally stop talking about Ember slow rendering performance and focus on more important things. Right? Like that's the main win we get from this. Besides actually being able to render those super rare scenarios in which that level of rendering performance is actually relevant, which is, and most likely none of us has ever worked on a project where that's the case. A really nice thing about the Glimmer VM that I wanted to say, though maybe not everybody is aware of that, the Glimmer VM was released in Ember 2.10, which is a minor release. So that means that releasing the Glimmer VM, although it was a total rewrite of Ember's rendering engine, was actually backwards compatible. And this is what we refer to in the community as stability without stagnation. Probably, or hopefully most of you have heard that. And that's obviously a really nice thing if you like live if you do front-end web development and still like do that in a stable ecosystem. That's also pretty rare, probably. So having talked about Glimmer VM, I now want to go back to Glimmer.js. And I think the first question is, what's actually the point of this? Why do we need this? And we also saw, we already saw how the Glimmer VM solved the problem of Ember being perceived as too slow for certain applications, and in some rare, probably rare cases, it was actually much slower and maybe too slow for like implementing some things. But another problem that Ember has is its size. So if you compare Ember to other frameworks like React, then you see that Ember's pretty big, right? So it's like way bigger than, for example, React. And many people will say, "Ooh, that's too big. I can't use that." But in a lot of cases, because Ember is much bigger than React because it does a lot more things, right? So that leads to the situation where in a lot of projects you end up with something like this, where the end result of building an application with Ember and building one with React is often at the same level in terms of bundle size. But just the distribution between framework code and app code is a bit different, while React only provides a bit, and the rest is code that you write yourself or code that you get from additional libraries that are not maintained by like the React maintainer community though, but are like maybe a bit more fragile in terms of long-time support. So that part of the application code is larger, while with Ember that part is smaller because the framework does more for you. And also the difference here in smaller app code also often means save time, right? Like all of that code you don't have to write yourself, you don't have to maintain yourself, you don't have to search for the add-ons you want to use for that functionality that's in there. So in large projects, I think Ember is larger, but that's actually what you want because you want to have all that stuff that's in those kilobytes of code, right? But in small projects or in projects where people want to migrate their static page to a more modern version, kind of using some JavaScript framework, you would end up with something like this, where you don't actually need most of what Ember gives you because you just want to have something that lets you render components, and maybe you just have like a small layer of application code because you don't have so much functionality and not so much complexity in the area of things that you're building, right? So Ember is arguably not a really good fit for these kind of projects. And there's not much to discuss about that. That's just a reality. We never really had anything to offer for these kinds of projects. So this change with Glimmer.js now, where we have something that is roughly similar to React in terms of functionality and in terms of size. Obviously, Glimmer.js is like React, deliberately limited in scope, so it's just the V in MVC. It's a very limited thing that just provides a component layer around the Glimmer VM. And sometimes that's just all you need, right? Like you don't need to have a router, you don't need to have services, you don't have to have a data layer because you just want to make something that, I don't know, adds some nice dynamic functionality to your otherwise static page. So how can you use that? Because we are still in the Ember ecosystem here, we can benefit from Ember CLI. So when I wrote this talk initially, you needed the Ember CLI master version. I think that's no longer true. The latest beta 2.14 or so works as well, I think. And then you would just create a new Ember or a new Glimmer app using Ember CLI with the blueprint for Glimmer applications, which is at Glimmer/blueprint. And then because we have Ember CLI, you can just switch into the directory, run Ember serve, and that builds and runs your Glimmer application just as it would an Ember app. When you look at the files that Ember new generated for you, you will see that the directory structure is a bit different. So you see there's no app directory, but a source directory with a UI directory that most of your app lives in, because UI and actually components and templates is all that Glimmer.js does. This is actually the new incoming folder structure that will come in Ember as well. It's known as the module unification IFC. It's like a big change that has been around for, or has been discussed for quite some time, and now it will finally, we have it in Glimmer.js and we'll have it in Ember.js soon as well. So the main thing to know for now is instead of your stuff being in the app folder, it's now in the source folder. Another difference is that you no longer have JavaScript files, but TypeScript files. That is because Glimmer.js is written in TypeScript, which obviously does not mean you have to write anything that uses Glimmer.js in TypeScript as well, but TypeScript is the default choice for now when you create a new Glimmer application. I have a few notes about TypeScript. So who knows TypeScript? Okay, so everybody almost. It's from Microsoft. I think an important thing to know about TypeScript is that it was, I think, invented or originally specified or whatever by Anders Hellsberg, who also did C#. And if you have never done .NET or C#, you should actually try it. It's like a really nice environment. C# is a great language. So having a kind of JavaScript-like language invented by the same person is probably a good thing. So this is pretty long, and most of you know TypeScript, so we just switch over this here. We can have a look at a few benefits, though. So one benefit is obviously that it helps you identify bugs, like a certain level of bugs that a TypeScript compiler could find would otherwise have to be found by running your test suite if you don't have types. Right, then IDEs have an easier time providing like help for you because they know what something can be and where it's defined and stuff. Also, having typed APIs makes it harder for larger teams to develop large applications. That's probably one of the main reasons why Microsoft builds it, probably for their own needs, but also I think that's something that their enterprise customers really benefit from. And this is actually not true. I thought it would maybe be true, but Benedict says it's actually not true because JavaScript is so weird and TypeScript can't really help with that. So what else do we get with Glimmer? So here's a pretty standard template from the application that we'll have a look at in a minute. First thing you notice is we finally have angle bracket components, which is something that we have been waiting for in Ember for some time, and for several reasons it never landed. So now we have that, so it's a much nicer way of using components. And the second thing that you will notice is we use this add syntax here, and that is used to distinguish arguments from attributes. So arguments are values that you pass to the component instance, so the instance of the component class, while attributes are just normal attributes. So if you would specify a class is something, then that class would be added to the root level element of the component. It would just be passed on to the DOM element, kind of, while those add things are actually values you can use in the instance of the component class. Also we have track properties. They are mostly they are similar to computer properties as you know them from Ember. They use decorators here to specify the dependent keys, but they're really similar. I don't really want to go into the details now. I think Yehuda Katz has a PR open, or maybe it has been merged already, where you would not even have to specify the dependent keys. You would just say tracked and it would figure out the dependent keys automatically, which is a big win because, yeah, it's just nice. Like you don't make mistakes by forgetting dependent keys or whatever. So like I said, we will look into a real application. And this is actually to do MVC, which we all have talked about to do MVC a lot in the Ember community and talked about how bad of an example that is for an Ember app because that's obviously the type of product where Ember doesn't make any sense. It's like way too big. You don't have any need to have any of the things you get from Ember. But it's a really nice example for a lightweight component library like Glimmer, right? So it finally makes sense to use MVC to evaluate a framework as long as it's like such a small framework. So we have the normal to-do MVC app here. We can say, I don't know, eat pizza is to-do, so I have a new to-do here. We can check that, then it's only completed. We don't have any active ones anymore. Then can go back and then clear completed, and it's really just like the normal to-do MVC functionality. Let's look at the. I think I cannot make this bigger here. No, obviously not. So I hope it's large enough. So you see we have the source folder here, and then UI in that, and components. And in there are all the components. So in every Glimmer application, you have a root level component that is called the same as the application is called. So in this case, it's to-do MVC-app. And that component obviously has a template, which is just a regular handlebars template, obviously with the square, the angle bracket component, the angle bracket tags for components, and these add syntax here for distinguishing arguments from attributes, right? So the rest of this is pretty straightforward. It's like almost the same thing that you use in Ember as well. So you would still use things like data down, actions up, and stuff. You would use actions the same way you used to. So it's all pretty much the same thing. So I think one example to look at is probably good is the checkbox here for toggling all to-dos. It's just a native checkbox, as you probably use in your Ember apps as well. Like you don't have to use the input helper anymore. When you're on a recent Ember version, you can just use the native elements. So it has an ID and class and stuff, and here we bind its checked property to the all completed property of the component. And then when we look at the component source code, we see that this is a tracked property that depends on to-dos, and it's true if every to-do is completed. So it's pretty straightforward. Just instead of a computed property, it's maybe easier to write it like this. It's just a normal property with a getter, right? So, but the underlying mechanism is really the same as for computed properties, more or less. The funny thing here is that if the value of that checkbox changes, meaning if we check the checkbox, then we call the toggle all action, which is just defined here. So it just gets all completed for each to do. Oh right, yeah, it toggles obviously. So it just inverts the completed for each component, and then commits them. Committing them here means, I think, storing to local storage or so. So that's not actually like Glimmer functionality kind of. The important thing to understand here is that, or to recognize here, is the toggle all method is just a regular method on the component class, as opposed to a method defined in the actions hash. So all actions are, or all methods on the component can now be actions. Right, that's probably the most interesting thing about this. Here, everything else yeah, it's probably can probably ignore it for now because I think I've been speaking for pretty long already. One thing that I wanted to show, though, because we talked about when do we schedule a re-render in a Glimmer.js application, and the place where that happens is here in index.ts, which is something that MSCLI will generate for you, so you don't write that yourself. But I highlighted that, but it's barely visible. So here you see that there's the setProperty.change function that accepts a callback that's being called when the property changed. And what we do is we just schedule a re-render, which would then lead to all the update opcodes validating their tokens, and if the tokens aren't valid anymore, actually like updating the DOM. If they're still valid, just ignoring that. And maybe this here is interesting as well. I mean, this here, like I said, every application has a root level component that has the same that is called like the application. So in this case, it's to do MVC-app. And when the application starts up, that component is being rendered into the container element, which in this case is just the element with ID app. But that's all code you never have to write. That's all maintained by MSCLI. You only write those components. So back to the talk. So we saw how the Glimmer VM works. We saw how Glimmer.js works, what it does. A last important thing that I want to talk about is Ember's future, because the existence of Glimmer.js obviously raises the question, where does this leave Ember.js? So we now have two frameworks in the Ember ecosystem and community. So does this divide the community, or does the existence of Glimmer.js mean Ember is now deprecated or whatever? Actually, both things are not true. So the answer to both of them is no. Instead, like I said, the main benefit that we all get from Glimmer.js is that we now have an offering for people who don't need a full-featured framework like Ember, because they only plan on building a very simple application where they don't need a lot of the things that Ember does for them. Or maybe they want to incrementally migrate their page from a static page to a dynamic website, and for them it doesn't really make sense to bring on or to bring in a heavyweight framework into that project from the beginning. Or maybe you are building something that has to run on very limited devices, so their mobile devices a few years old or so, where Ember would just not work. So we have an offering for those people now, and the good thing is, because Glimmer.js is also part of the Ember ecosystem and community, we have a clear upgrade path from that very simple framework for very simple applications to a more robust or more full-featured framework, which is Ember.js, which you can then use for more complex applications. So the idea behind this is you start out very simple and small with just Glimmer.js, and as your project evolves and gets more complex and gets bigger, and you start to need more things that a framework could provide you, then you would just install your way up to full Ember by, first of all, for example, installing a router, then installing a service, and then installing a data layer. And as opposed to other ecosystems where you would actually have to pick one router from a plethora of routers available, and you have to figure out which one is the one that works best for you, which one will be maintained in the long term. Instead of doing that, you would just install the Ember router and the Ember service layer and the Ember data layer. So you are still running on one community maintained stack, but you cannot choose how much you need from it. Obviously, this is more of a mid-term to long-term goal, so we're not actually there yet. What you can do, though, is just make the switch from here to here in just one big step, which is still pretty good, right? Being able to upgrade your project once it gets more complex. So what you can do is you can just take all your components from the Glimmer project and copy them into an Ember project. So it means you never have to rewrite anything once you make the switch. You just like reuse all your stuff from Glimmer in Ember, which is pretty good. The next step in terms of making progress on that timeline kind of is extracting an Ember router package from Ember, because that would in many cases be the next thing that people who start out with Glimmer.js will need, like some sort of routing service with the loading state and error state support that we have and Ember and all those things. Also, and this is really another big benefit of Glimmer.js, is that the router implementation, as I heard from the core team, is not like in the best state, kind of, and we need to experiment a bit with new approaches to that problem. The problem, though, is that we cannot really, Ember's stability guarantees that are really important, and like a massive advantage of Ember versus other stacks make it a bit hard to experiment with new things, because you have to make sure everything stays backwards compatible all the time, and you can't really like introduce breaking APIs. If you want to introduce new things, you would have to have like an opt-in mechanism, making everything very hard, right? So the good thing is that we now have the possibility to extract something, validate its functionality in Glimmer.js projects, and only then, once it's validated and it's proven to be stable, replace the implementation in Ember in a backwards compatible way using that new package, right? So that is the goal, that we write a new router or highly refactored router, validate that in Glimmer.js projects, and then just use that internally in Ember without anybody even recognizing, because public API would stay the same. So that means that that Ember will also get better because of the existence of Glimmer. Like there's something that Glimmer unleashes, kind of the possibility to do these kinds of experimentations. So wrapping up, Glimmer.js is really nice. There's a lot of sample projects on the Glimmer organization on GitHub, like to do MVC and some more. You can also have a look at the Glimmer API docs, which are implemented in Glimmer. Of course, they are a proper progressive web app with the service worker and stuff. Like they show what Glimmer can be used for. Really, and as the Ember community, we should really use Glimmer as an opportunity to market our ecosystem better, because we can now reach more people that we could not reach before, and we should make sure we do that and talk to people like how good Glimmer is, and that they can now be part of the Ember ecosystem without taking on the load of like the full-featured desktop level framework. And that's it. Thanks. And if there are there are questions.
Yeah, I have a question for maybe both of you guys. So you're using Glimmer uses a lot more TypeScript, and I'd just like to know about TypeScript. What violence does TypeScript do to our ability to recognize patterns? If you, supposing you compile TypeScript for ES6 support, you can do that?
Well, there's no decorator support in ECMAScript, so decorators are easy.
Right. But how about these reference classes and all this stuff?
That's compiled, that's easy.
Okay, that becomes ES6 classes?
Yes.
Okay.
From my point of view, the interesting part is that the more you do TypeScript, the less you don't have to do, because it wasn't your speech, yeah? The more you get to the target specification, the less you have to transpile.
Yeah, that's true.
Yeah? So obviously, this kind of TypeScript thing is leading where you're heading.
Right. So there's obviously TypeScript is not yet specified in terms of ECMAScript.
And the wonderful thing is that it's happening and that you're going there, because then these things, which are absolutely genius. I never heard about Ember before.
All right.
So I'm
That's why
totally
you showed us
impressed.
Ember.
I have to say that, because
Good.
the next sentence is a little bit nasty. The more they do this kind of things in years whatever next, yeah, the less we need all of that stuff, because we're getting a mature language.
Yeah.
I mean, you still need something like the Glimmer VM, or so. That's not something that's eventually going to land in V8 or so, right? That's still like application level code. But
What you're doing is, I was a Java programmer at some point of time, yeah, and Java is object-oriented, and I love it. But if you really create a lot of objects, the VM has much to do. If you change all that objects to arrays, it will be radically fast. Because it's even faster. But then you lose object orientation. And here's the trade-off, obviously. And what you're currently doing is you take ECMAScript and replace it into arrays, which is a much better idea because it's the best thing to do on a processor.
yeah, but I mean, like, what the Glimmer VM does, it turns handlebars into an array of opcodes. That's
Yes,
then.
you do some optimizations which are perfect for a limited risk processor. You do that,
Okay.
and you don't even know because you never programmed the risk processor.
Right.
Maybe.
I did not. But
Yeah, so therefore I can recognize that pattern because it's all about patterns.
yeah, another
So
question.
I'm just curious if the same LTS guarantees that currently exist within the Ember ecosystem are going to be extended to Glimmer. I mean, one reason to adopt Ember after a larger organization is because of those LTS guarantees.
Yeah.
What does that look like in terms of Glimmer?
I mean, right now, Glimmer is probably not mature enough to like offer any of those guarantees, because like it's still pretty young. It was released in March, but still, like, you know, there was a conference keynote in March, so maybe it was a good thing that was released then, right? So, and maybe that release was driven more by time than by maturity, right? So it's not really like at a stage yet where it could make any long-term promises, I think. I mean, I don't really know what the plan is, but I think you could very well imagine that you would have the same sort of semantic versioning and release chain that we use for Ember for Glimmer as well. Like, why not? Because the API is so small, it's not really a huge commitment anyway. Also, you would not, you would still not use the ability to experiment with new things, because the Ember router, for example, would not be a part of Glimmer anyway. It would be an optional add-on kind of that only needs to be supported and needs to make those long-term guarantees once it reaches 1.0, which is after the experimentation phase anyway. I mean, for now, I think the biggest value of Ember's like long-term guarantees kind of is that for people who want to use Glimmer is that they always have an upgrade path from Glimmer to the stable Ember ecosystem if their application reaches a point where that is necessary. Yeah.
What would you say are the main selling points to adopt Glimmer now if you're starting a new kind of small project or enhancing a site with dynamic contents compared to, for example, React or Vue or something like that?
Yeah.
Because from my point of view, it's not possible to use all of the Ember add-ons that are out there, correct?
Right.
Because they rely on Ember.component and
Right.
set and get and
Right.
all that stuff.
Yeah.
So even though there is this ecosystem that's quite large, and of course there's Ember CLI, which makes building and serving the application very nice and easy.
Right.
There's not a lot of stuff you can build upon.
Yeah. I think the main selling points for Glimmer are the selling points we used to sell Ember, because the selling point for Glimmer is not the performance. The performance is not relevant. We only need the performance so we can talk about other things, right? So nobody can say we have this crazy benchmark here which shows that Ember or Glimmer is so slow and whatever. Like, that means I can't use the project, which is almost always stupid. So the performance is not so relevant in terms of selling Glimmer. I think the main selling point is that we have something that's lightweight if you need something lightweight, but this lightweight thing also has an upgrade path to something more mature kind of and more full featured if you need such a full featured thing. And I don't think any of the other frameworks really has something like that to offer. For example, if you compare with React, at some point you need to choose one of the boilerplates or whatever, and then there's 5,000 and you don't know which one to use. And with Glimmer you have the upgrade path to that super stable ecosystem without stability, without stagnation mantra and stuff. I think that is really the main selling point for Glimmer.js right now. Besides it being actually pretty nice, but that's like probably that's probably not the main selling point.
Yeah. And of course, you also not only you would want to include Ember components in your Glimmer app, but also the other way around, because as you said, you can just copy the Glimmer components into your Ember project.
Right.
Currently, you have the different models of how a component receives its attributes.
Right. So the Glimmer component model will eventually be the new component model for Ember as well.
But it's like you said, the mid-range plan, not right now.
Right. So this is a community project, so there's always there's never enough people doing the work and never enough time. So this is all pretty there's lots of constraints, but I think we're on a good way.
Have you already used it in a real project?
Yeah, we did. So we contributed a bit to the API docs project, added a service worker and stuff, which is not really related to Glimmer because the service worker you're basically on your own anyway. But we did contribute to that a bit. We somebody ported there's an asteroids version written in React, and somebody ported that to Glimmer, and then we helped with that a bit. So yeah, it's really nice to use, nice experience. Also a pretty familiar experience if you use Ember. You just continue using Ember CLI, so super familiar. Just making the switch from JavaScript to TypeScript is pretty straightforward. Because TypeScript is opt-in anyway, you can just not use it, and then it's still TypeScript. And yeah, it's pretty good.
Just start using it without a lot of child errors, something like this. Basic things to fix. You just start using it, and you're basically happy.
You just have to be aware of the few differences that are showed, and there's a few other ones. But making this or using Glimmer when you have used Ember before is super simple. Also using TypeScript is really simple. So no big step there. Yep.
You mentioned that it's only kind of considering V in MVC, and
Yeah.
with the controls and data could be somehow connected there with Node.js or with other frameworks, basically.
Yeah, I mean, like V and MVC is a bit like that's maybe not true. Like the V and C are both the component. Like the component is both like the V and the C. So you have it's actually the V and C and MVC kind of. You can use any model layer that you want to use with it. Also, the to-do MVC app actually uses a router. I don't know the name of it. It's just some router package that sets depending on the route, it sets a state on the application component, and depending on the state, that would like render different things. So you can combine it with any kind of router or data layer or whatever you want to use. Like a router and data layer not being included does not mean you cannot use them. It's just not included, and there's no add-on available yet. So like I said, the Ember/router, Ember/service, Ember/data are planned but not there yet. But eventually you will just use the community maintained standard solution for routing and services and data and so on. Good, then. Thanks, and see you next time.